the hepatocellular carcinoma is one of the major causes of human death worldwide, especially in China. The major cause of this malignancy is chronic infection with hepatitis B virus. And this is much more happens here in China. So this project is focused on how this HBV chronic infection can cause the hepatocellular carcinoma, by what kind of mechanisms. So in this project, we ever found during the HBV-induced hepatocarcinogenesis, and we found these viral mutations, viral evolutions, and they interacted with the genetic predisposition, or we can call it inheritance, and they can work together. You mean the genetic inheritance might predispose the human beings to have some very weak immunity against the HBV. And in the weak immunity against the HBV during this environment, the HBV cannot be eradicated. They are forced to mutate to a mutant HBV. And this mutant HBV got much higher capacity of induced cancer by several ways. One of the major ways is for activating the oncogenes and suppress the tumor suppressor, and even the integrating the host genome doing something like this. So the genetic predisposition might predispose the chronic inflammation, and chronic inflammation might be prerequisite for the occurrence of a hepatocellular carcinoma. So in this project, give us a very common sense, that is, any kind of cancers, they have a precancerous change, and this precancerous change mostly is a non-resolving inflammation, and this kind of inflammation that cannot be treated. I mean, this is a very silent, not very violent, but can cause these genetic changes. And this is one of the genetic predisposition. And the second one, that is the much more important one, that is, the human cancer, any kind of cancer, they have the problem is that there's large somatic mutations. And these somatic mutations was caused by an enzyme called ApoBax. And the balance between the ApoBax and the UNGs, and the ApoBax facilitated the somatic mutation. UNG can correct that kind of mutation caused by ApoBax. So this balance keep this our integrity of our host genome. But sometimes during the chronic inflammations, the inflammation or pro-inflammatory molecules can upregulate this ApoBax and downregulate UNG. And this kind of circumstance much more happens in the people with the genetic predisposition of this for the chronic inflammation. So in this circumstance, they generate a large amount of the somatic mutations. And most of the mutated cells, or even the HBV, they are eradicated by immunity or by the hostile living environment. Only a very small percentage of these cells got the opportunity to survive and become redifferentiated, called de-differentiated into the undifferentiated cells. And they have a much more of these somatic mutations. They call it new creatures. This is called a tumor initiation cell. And that kind of cells can proliferate themselves in the locus where this inflammation is going to be very, very silent. The pro-inflammatory environment is keep consistent over there. That means the cancer can be generated. So in this project, I proposed one of the most important mechanisms, or even the hypothesis that is called cancer evolutionary development. And that kind of series is the a common pathway of chronic inflammations cause cancer. A lot of cancer was caused by the chronic inflammation, and a lot of cancer can be caused by the same pathway, that is apoBAX upregulated, UNG downregulated, and this balance become from the balance to imbalance, and it causes accumulation of the somatic mutation, and eventually lead these cells, normal cells, from diploid cells to the haploid cells, and then probably generate a lot of different kind of mass in their nucleus, that is cancer cells. So this project will tell us the first very novel mechanisms by which HBV all causes inflammation, and inflammation causes cancer. And HBV itself also participates in this carcinogenesis process. The second one, that is, given that we understand the mechanisms of the HBV-induced cancer, we know how to stop this carcinogenesis process. That means we set up a specific innovation to stop the progressions of this disease, stop the progression from the chronic inflammation with the HBV to the liver cancer. So we got a specific prophylaxis, that is, the people we know, the HBV infected people, we give them the different degree of the risk. And the high risk population, we need to focus on the specific prophylaxis, that means use the antibodies, use the antivirus therapy to eradicate this virus, this dangerous virus. I mean, usually the antivirus therapies for 5 consecutive years can greatly reduce the occurrence of this HBV-caused cancer in high-risk populations by 75%. And another issue, that is, the people who already got the HBV-caused cancer, after surgical treatment, these people gonna be relapse very quick. Okay, we know what is the risk of people. What is the risk of the people relapse? I mean, how to stop this disease, HCC relapse? We give them the specific antiviral treatment. We know the higher viral load and all the mutations facilitate this recurrence of this HCC after surgical treatment. So we give that kind of people a specific treatment with the antivirus, and then we significantly prolong the survival of the people who receive the surgical treatment. So in this project, we know the mechanism by which the HBV cause this cancer or cause this recurrence after surgical treatment. And we also know by these mechanisms, we also know what is best options we can use to stop the occurrence of disease or stop the recurrence of the disease. So this kind of project make a lot of sense for our fighting against hepatocellular carcinoma, HCC, the top killers in China. That's it.